Extremely important video to understand line of best fit at each level, starting from grade 9 to grade 12, including IB students. We will provide a solution to find a simple line of best fit using the average point for grade 9 and 10, and then we'll use the method of least square distance to find the best fit. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll discuss concept about line of best fit. Now this is extremely important for students from grade 9 to grade 12. Now at different levels, you actually draw a line of best fit from a scatter plot using different approximations. So we'll consider one simple approach which fits for grade 9 and 10 students, and then we'll take up a least square method which fits for grade 11 and 12 and especially IB students. The question here is, table shows the data for the rabbit and wolf population since the year 2000 in Jasper National Park. Now it is believed that rabbits being food of wolves, if there are more number of rabbits, there will be more number of wolves. Well, just for the curiosity sake, in Jasper National Park, we have around 45 wolves at present. Now, the question here is, use a scatter plot to classify the correlation between rabbit and wolf population. Part B, question 2 is, find the equation of the line of best fit analytically. So, line of best fit analytically. So, we'll see how this word plays a very important role in understanding and answering the question. And question number 3 is, predict the population of wolves if there are 200 rabbits. Now, as I said, the approach is to take care of grade 9 students and also 11 and 12. So, how are we going to approach this particular question? We are given the information here, the number of rabbits in 2000, 125, wolves 28, 150, 34, 190, 42, 160, 40, 146, 38, 126, 29, 96, 23, 94, 18. You can see from the table that if there are more number of rabbits, then there are more wolves, right? Less rabbits, less wolves. So there is a correlation. It seems to be a positive correlation. If you draw a scatter plot, you can definitely get the correlation, right? So I'll get back to these formula a bit later. Let's look into the scatter plot first. So what I've done here is plotted a scatter plot. So we have put rabbits on the horizontal x-axis, right? So this side is rabbits. And this is wolves. These points are simple to plot. However, the key is, how do we draw a line of best fit? So the best thing is, from the given data, add all the x values, which are for us rabbits, and divide by the number of values given to us. And in this case, we know that the number is 8, right? So n is equal to 8. And y is dependent on rabbits, and therefore wolf has been plotted along the y-axis. So when you plot, you find the mean of x value and mean of y value, correct? So the average of x is sum of all the x values divided by n, average of y is sum of all y values divided by n. And if you add all of this, right, then the sum here is 1087 for x. This total sum of x is 1087. And sum of y, when you calculate, is 252. Now dividing by 8 will give us the average value of x and y, which comes to 135.88 and 31.5. So if I draw a line around 135 and 31.5, we get a point somewhere there. Now this is the average x value and average y value which we have got. Now that point has to be on your line. This is very important to understand. When you're drawing for grade 9, 10 students, the line of best fit. Now you can put your ruler and draw a straight line which goes so that the distance from the points above it and from below it is almost the same, right? So at least as you can see here. So we have drawn a line. You can always, once you have the line, you can find this equation of the line by taking 2 points on the line, right? Let us say we take 2 points on the line, find slope, change in y over change in x. So that gives you the slope m, right? So you can say m equals to change in y over change in x. And then you have this particular point. And we call this point as the average, which in our case is x value of 135.88 and the y value of 31.50. And using this point, you can get the equation of the line, right? So that is how you can do. Approximately the equation will be y equals to 0.25, it is a positive slope, x and some value here may be around, let's say minus 2.4. So if you do the calculation, that is what you will get as the equation of your line. Now that is simple. Now sometimes we need more accurate result, and that is why in this particular question we have the part which says very clearly that we need to, let me highlight this, use scatter plot to classify the correlation between the rabbits and wolves. So we got that part which is positive and strong, correct? Now the second part is line of best fit analytically. And when we want to draw this line of best fit analytically, we normally use a formula. And this is the formula which is right there for us. So well, the equation of the line is y equals to ax plus b, right? Y equals to ax plus b. However, the value of a and b are given by the formula. So a is n times sum of xy values minus product of sum of x and sum of y divided by n times sum of x square minus sum of x whole square. So that gives you the gradient a. And to find the value of b, it is kind of similar to what we did in the scatter plot. You need to find the average point, x bar and y bar, and use this particular formula, taking a from there, and so you get the value of b. Once you get the value of b, you can substitute a and b and get the line of best fit. That is what most IB students are required to do. And in grade 11 and 12, if you've taken statistics for higher level, then you follow this particular method. So that's the formula given to you. Let us see. From the given data, how do we organize the data and find the values? That is what we'll see now. So we have already seen this standard scatter plot, which is good for grade 9 students, okay, or even 10. But now let's move forward with grade 11 and 12 IB students. How do they work on it? So what we have done here is written the data in the table, X values for rabbits, Y values for the wolf, and then we have added them up in the last line. So sum of X is equal to 1087, sum of Y is 252. Now in this formula, since you have product of X and Y, so we have a column, product of X and Y, and then X squared, so we have another column for X squared. Add them up given in the last column. And now these values can be filled in to find the value of A, correct? I'd like you to pause the video at this stage, at least plug in these values and calculate for yourself what is the value of A, right? It's a good exercise. Now those of you who want to learn from me, they can always send an email on the address given. Most of my students are doing extremely well. Some of them are right there on top of the class getting awards and scholarships like Akshay.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is Akshi Kandivani.
Great. Our student Akshay gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel. So I hope you have filled in these values and calculated the value of A. Here is my calculation. So what we have done here is that we know N is equal to 8, right? Number of elements which we have taken as 8. And XY is right there, the sum 36082. X and Y sum 1087 and 252 have been written here, multiplied, and then in the denominator we have 8 times X squared sum and X squared. So X squared sum is 155,069 and X is 1087 whole square. Once you calculate, you get approximately 0.249, which I have approximated to 0.25. Okay. Now I've used this value 0.249 to calculate the value of B. So I hope this table is absolutely clear. We need to get y equals to ax plus b. We have calculated the value of A right there and approximated that to 0.25, correct? Now let's move on and see how do we find B. So you need the average point which we calculated earlier. So A is 0.25, X, the average value, is 135.88, Y value was 31.50. Using the value of A from our previous calculations, we can find B as Y minus AX. So we get minus 2.4 as the value of B, and that gives us an equation Y equals to 0.25x minus 2.4. So that is the wolf population given the number of rabbits. You get the idea. Now part C was, how many wolves do you expect if there are 200 rabbits, right? So if the rabbits are 200, plug in 200 for X, right? And calculate, it comes to 47 point something. So we'll just assume the lower part, right? And 47 wolves are expected. So that gives us 47 wolves. That seems to be quite right, since for 190 we already have 42. So if I extend the graph which we had got, we will get that kind of result. So I think with this, you understand the basic concept of how do we apply the formula and calculate the values. Perfect. And also you see the graph. Now here is the graph for your interest once again. Some of the students are finding the regression factor, right? So let us see how do we calculate regression factor. Well, we have calculated this value using Excel sheet. The formula it just calculates both equations and the regression. Our equation is fairly close to what we got by the calculations, right? Now, regression factor R can be manually calculated from the graph itself by using the strategy that R is equal to 1 minus ratio of smaller side to larger. Now, what is the smaller and larger? Basically, what we do is we make a rectangle, right? So, along this line, we make a rectangle, right? Including all the data. Do you see this rectangle? Right. So, what you can do here is you can measure the length and the width. Correct? So, this length here is the smaller side and this is the larger side. Do you see that? So let me write down. So that is the larger length and this one is the smaller. So the ratio, that is how much do we deviate from the line, this width ratio, smaller over larger, 1 minus that gives us the value of R. So if you calculate this in the given scenario, it comes to around 0.9. Correct? So here you will also note that this scale is slightly much wider, right, than this, right? So, but if you have an equal scale and then we measure it, you'll see how close this is, right? So it is actually very close. So you could actually also find the regression by using this particular formula, which is also used by many students learning statistics and understanding the topic linear regression. Perfect. So I hope with this you have learned a couple of things. We started with a very important data collection from National Park. So this is kind of an approximate data which we have. It's not the real data, right? Now, we have drawn the scatter plot and we have understood how do we approximately draw a line of best fit. So the key was to find the average center point, which is x bar, y bar, right? Average of x values, average of y values. And then approximately draw a line which goes through that. And then we can use y equals to mx plus b formula to get our equation, correct? Perfect. As far as the senior students are concerned, they have to find the gradient using the given formula, for which the data has to be reorganized, finding the values of x square and xy, and some of these will be used in the formula. Find the value of A. Once you find that, then you can find the line of best fit by finding the value of B using the value of A and the average values of x and y. Perfect. So that is how it is to be done. And lastly, we also showed you approximately how do you calculate the regression factor from your graph, right? So that's an approximate method. It works. So with that, we end our video. I hope the concept is absolutely clear. Feel free to write your comments and share your views. In case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.